I don't have any nice slides for you to look at, but if you go to devternity2019.jbrains.ca, you'll see notes for this entire talk, which means that you don't have to worry about writing anything down. There will be no slides for you to photograph, so you can just focus and be here. And I know that people have been asking questions in the Slack channel, but if you also ask questions here, or just paste them into here, then I promise that if I get the chance to answer some of them, I'll answer them here. And whichever questions I do not answer here, I will answer online and publish them at some point. So I promise I will answer every question, if there are any. It was a bit of a difficult travel night last night. We arrived at 2 o'clock in the morning after an evening trip, but I'm really happy to be here. I wish I had had a chance to come here earlier today because I missed some talks from some people that I really wanted to see speak, so I'm glad that those things are recorded. And now, what do I mean by the well-balanced programmer? So, sometimes you just have a stupid idea, and then, because it's a stupid idea, you have to tweet it. And so you just tweet it and you see how the world reacts. And I had one of those stupid ideas, just a little joke that said, you know, the junior programmer's bookshelf is 80% platforms and frameworks and APIs and libraries and reference material, and the senior programmer's bookshelf is 90% applied psychology. And I just thought, okay, well, that reflects the difference between being a junior programmer and a senior programmer. And I really didn't expect anybody to find that joke particularly funny, like you didn't. And suddenly I noticed that there were several hundred retweets and then close to 1,000, and I realized that I'd kind of struck a nerve. And that's a little bit what I want to talk about today. That the well-balanced programmer has to do with how do we work as programmers, and the extent to which maybe we focus a little bit too much on just the pure technology part of our job. So I promise I will talk a little bit about technology or code, but I will talk about some other stuff too, and it might get a little personal and it might get a little uncomfortable, so I'm warning you now. First though, so I sort of think of 3 major themes in how programmers work. There's writing the software itself, so there's actually writing code. But then there's also planning the work and navigating the people. And what I'd like to do today is to give a little bit of an overview of some core techniques that I use in these 3 areas, with the hope that for some of you, this is old news and you should just keep doing what you're doing. You're already probably quite well-balanced programmers as it is. And for those of you who maybe feel a little bit of imbalance in your work, then maybe these can give you some starting points to become more balanced in your work and practice as a programmer. And what I mean by balanced really has more to do with, well, let's just start with something very practical. How many people in the room think that they know what I mean when I say theory of constraints? Okay, a handful. So those of you who do know this know about the thing called the bottleneck. So everything in the world is a system. I'm a system, you're a system, we're a system, my left hand is a system, this machine sitting here that's powering that one slide is a system. Everything is a system. And theory of constraints is based on the idea that in any system, what we're probably interested in is the rate at which that system produces some kind of result. And not just how much of it is produced, but the rate at which it's produced. So with software delivery mechanisms, like the teams that we work on as programmers or testers or whatever we do for a living, we might measure that in running tested features per month. And the idea there is running is important because we actually want to see the software do something, not just be an idea in someone's head or words in a document somewhere. Tested because we'd like the software actually to work. And features, meaning that what we produce is actually of value to customers. It's really not that much use for us to build something if no one's going to use it. And so, for example, we use running tested features per month or per week or per hour, whatever time period seems reasonable to you, as a measure of what theory of constraints calls throughput. Throughput is the rate at which the system turns its inputs into outputs. And so we measure a system's value, let's say, by its throughput. Might not be the best way to do it, but it provides a useful model. Now, the throughput of a system is rarely infinite. If it were infinite, we would go home. We would take a vacation because we've done our jobs. You can be sure that the throughput of any interesting system is finite. It has a limit. And what that means is that there must be some part of the system that limits the throughput of the overall system. That's the constraint in theory of constraints. And so we call that, because we like metaphors, we call that a bottleneck. So when you hear people talking about the bottleneck, they mean the part of the system that limits the throughput through the entire system. So think about an actual bottle. The neck of this bottle is smaller than the body of the bottle because it's an intentional constraint. It's so that when I do this, don't worry, it's not open. When I do this and water comes through, I can control the flow of water. That's the point of a bottleneck. Now, in some cases, a bottleneck is intentional. We want to intentionally limit the flow. This way I don't put water, is this? Okay, good. Negazet's good. Sometimes we want to intentionally limit the flow of whatever comes through the system to avoid, soaking the people in the first row. But often the bottleneck of a system is the thing that we need to pay the most attention to. In our practice as professional software people, people involved in building software in exchange for currency units, usually the bottleneck is a problem because we don't want to limit throughput. If our throughput is running tested features per month, and we want as many running tested features per month as possible. What this naturally leads to is the idea that when we're thinking about how to change the way we work, we should probably take a look at the bottleneck. Since every system has a bottleneck, there must be some place where the throughput through that part of the system is what limits the throughput of the entire system, and that becomes an obvious place to start. And so one of the hard lessons that we've learned in the Agile software community over the last 20 years is that if we just give you a bunch of rules and ask you to follow them, that creates chaos. Right? We tried that with extreme programming. Some people tried that with Scrum. Some people are trying it with Scrum now. Some people have the plan to try that with Scrum starting on Monday. What we do instead is we recommend people look for the bottleneck in their system and then try to find a technique, a tool, something that will help them address the bottleneck. If I can improve the flow through the bottleneck, then I should be able to improve the flow through the entire system. And you found the bottleneck because if you make this part of the system better and more stuff comes out, that was probably the bottleneck. And you also know that if you spend all your energy trying to get better at this and nothing changes, that definitely wasn't the bottleneck. Well, maybe definitely is a bad word, but probably wasn't. Now, why do I bring all this up? I bring all this up because for most people, most of the time, their biggest complaint in adopting any new way of working, test-driven development, domain-driven design, let's adopt some ideas from Scrum. Let's try this extreme programming thing because we're hipsters, and we were Agile before it was cool. In adopting those principles or those practices or those techniques, the common complaint is always, I don't have time. You've said this, I've said this, and the one real problem with the phrase, I don't have time, is that it's not a problem that anyone can really solve. Physicists somewhere right now are working at trying to make time flow more slowly. I don't think they figured it out yet. There's something about, traveling near the speed of light, blah, 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 but it's hard to write software when you're traveling at the speed of light, so let's assume that we're never going to be able to create more time. And as long as you think of the problem as I don't have time, I don't have enough time, then you will stay in a state of learned helplessness, which is one of those fancy, annoying pseudo-psychological terms for getting used to the idea that you can't do anything to improve your situation. Learning that no matter what you do, things won't change. It's really not a great place to be. So instead, one of the first things that I like to do is to play a psychological trick on you, I promise, for your own good. where instead of saying, I don't have time, that you use a more honest phrase that actually captures the problem better. And that is that you have too much to do. Now, I remember first seeing this phrase, again, I'm one of these old extreme programming people, so I remember reading this phrase for the first time in the book Planning Extreme Programming by Kent Beck and Martin Fowler. Yeah, that whole thing about Scrum is what adds planning to extreme programming was never true. When I read this for the first time, there was just a chapter called Too Much to Do. Occasionally a phrase just hits you in the head like you'd been asleep your entire life and suddenly you wake up. And that's what it was for me. And the nice thing about saying too much to do, instead of I don't have time, is that it encourages you to try another solution. And in fact, even more than you have too much to do, the real problem underlying our anxiety and our concern and our difficulties in working as professional software people is not even just that we have too much to do, but it's that we continue to try to do too much. So one of the obvious solutions is to figure out how to do less. And that's where I want to start. So when I just tell you, well, the problem is you have too much to do, you should try to do less. So the Heath brothers, who wrote Made to Stick and Switch, they had a really nice phrase for this: true but useless. I think we can all agree that probably in our professional lives, we're all probably trying to do too much. But if I just tell you that you should figure out how to try to do less, that doesn't help you get started, right? We have to do what they call scripting the critical first few steps. And that's part of actually what we tried to do when we tried to popularize techniques like test-first programming, continuous integration, and frequent releases in the early 2000s, that we were trying to encourage you to do fewer things. In fact, it's right in the Agile Manifesto. If you go past the first 4 lines and you actually read the 12 principles, one of them says, simplicity, maximizing work not done, is essential. Now, that's a nice poetic way of saying it. Here's a more honest way, or a more direct way of saying it. Figure out the 70% of your project that you should never have done, and don't do it. Okay, how do we really get started? How do we as individuals get started doing this? And my idea is that if you start in this area, then you'll be able to find more balance in your work. So let's talk a little bit about code. For me, the one single biggest technique that I've used over the last 20 years that has helped me figure out how to do less when writing code is evolutionary design. Now, some of you who know my work or who know me personally were probably expecting me to say test-driven development. Haha, tricked you. But that's okay, because remember, we're programmers and we're accustomed to being focused on implementation details. And I'll say this about test-driven development: it's an implementation detail. Test-driven development is not, nor was it ever supposed to be, the goal. The goal was evolutionary design. Now, why is this technique powerful? Or even, before I go there, what do I mean, right? Test-driven development is the implementation, evolutionary design is the interface. So what do we mean by evolutionary design? So let's think about how some of us, older of us in the group, were taught how to do design, possibly in school or possibly by other people who had more experience. What they suggested was, well, when you think of a problem that you want to solve, some features that you want to build, some system that you want to build, what you do is I'm going to screw with the cameraman for a moment. What you do is you go into a dark room and you just think for a while. I don't know, a week, 2 weeks, 3 months, something. And you think really, really hard about all the details of what you need to build. You think about how they're all going to fit together, how to organize all the pieces. And you sit there and you just think really hard. Because you're a smart person, so this should be easy. And then finally you emerge after 3 months and you draw all your thoughts down on pieces of paper, and then you hand those pieces of paper to people who will write the code for you. Sometimes you just keep those pieces of paper for yourself, and then you sit down and finally write code. Now, I know none of you are silly enough to do it that way, but there are some people who were taught to do it like that. And the one real difficulty with this technique is that no matter how hard you think, no matter how long you think, no matter how carefully you think, you will not imagine all the important details in the system up front. We've been trying to do it for 50 years. There might be 3 people on the planet who are capable of doing it for a system that's big enough to solve a real problem. I've never met any of those 3 people. I doubt they exist. If they do, I really would like to meet one, because I'd love to understand exactly what makes them tick. Somewhere out there's got to be a Mozart of software development. I've never met them. So what should we do instead? The problem with this technique is that at the beginning of the project, before we actually write any code, and I shouldn't say that. The beginning of the project, of course, is not the point where we're about to write code. But before we start to write code, and we think about how should we organize code, how are we going to build the modules that will talk to each other through this nice directed acyclic graph of dependencies, all that good stuff. At the point when we sit down finally to write it, to actually type it into the computer, this is the point where we are the most ignorant about what design will solve the problem. This is when we are the most ignorant about how to organize the solution. We have some ideas, but I'm sure you've had the experience like I've had it, where as soon as you start to try to write the code, you start to realize that some of your ideas didn't quite work. One of the most common examples of this is there are 2 parts of the system, and we're going to work together. And there's this piece that we have to do, and I thought I was going to do it, and you thought you were going to do it, so we both did it. And the problem is that we both did it a little bit differently. And then when we tried to put those 2 pieces of the system together, there's no way to put them together. Right? Then we have to figure out who's going to delete their code. Is it going to be you? Is it going to be me? I don't know. So then we argue about it for 3 weeks. Probably no resolution. That's one common outcome. Another very common outcome, the exact opposite, right? I thought you were going to do it, and you thought I was going to do it, so then nobody did it, right? So your code reaches this far, my code reaches that far, and or it's the so-called channel problem, right? When they were building the channel, this is a absolutely fake story, but it illustrates the point really well. That when they were building the tunnel, that people were building the tunnel from England, people were building the tunnel from France, and after a while they started to realize they're not going to meet. So then they had to, so that the tunnel would actually, otherwise you'd have very soaking English people and very soaking French people. So we have these problems, and we don't encounter these problems until we actually start to write the code. So it becomes essential for us to become more comfortable making those design decisions later. And the whole point of evolutionary design is to encourage us to learn how to feel more comfortable making those design decisions closer to the moment when we actually need to make them. Not back there when we think we know what we need, but here as we're discovering what we need. And the idea then is that we should be alleviating one of the bottlenecks in our system, which would be all those design mistakes that we make. All those situations where we do this, or we do this, and we end up having to rework our work. And I don't know about you, but those things always caused me significant stress. There's really few things that I experience as more stressful than believing that I had finished something and then finding out that it wasn't done. Or believing that I had finished something and finding out that it didn't work. So we could, in principle, use the techniques of the ideas from theory of constraints to help us solve these problems. And there's a wonderful talk that Corey Haynes gives that illustrates this. It's one that he and I have sort of worked on together a little bit, where you can go from the waterfall to Agile in 6 easy steps. I won't do it now, but the idea is that you're constantly addressing the bottleneck in building software. And if your bottleneck is bugs, then you start doing test-first programming, and suddenly you actually become good at writing code that works. And at some point, bugs are boring. Yeah, you make the occasional mistake, but you fix them fairly quickly, and pretty soon you realize that your bottleneck is now this thing that I was talking about with design. So then you practice test-driven development. And in the beginning, you start to notice design problems, and then you fix them by refactoring. And then you write some more stuff, and you notice design problems, and you fix them by refactoring, and you continue like that. And now, at some point, refactoring code kind of becomes boring. Yeah, we still make the occasional design problem. We still have this, or we still have this, but we know how to refactor our way out of it safely and even gracefully. And then eventually, somebody wants to put a refactoring task on the plan. Somebody says, oh, this is great, we can add these features, but we need to do 3 weeks of refactoring first. And as soon as you say that, an architect hears you, or a project manager hears you, or a product manager hears you, and says, no. So you learn how to work in very tiny steps. And the idea of working in very tiny steps, by doing, say, TDD as if you meant it, or Kent Beck's wonderfully crazy test and commit, otherwise revert, you learn how to create a tiny mess, clean it up quickly. Create a tiny mess, clean it up quickly. Create a tiny mess, clean it up quickly. And what you notice is that you're constantly in this state of tidying up your code, but there's never a big mess anywhere. And I don't know about you, but when I reached that point where that became boring, wow, was my stress level lower. Because then I didn't have to worry about, well, are we going to be able to design the system in a way to meet the needs of the customer? Well, probably. I mean, we've been doing it for a while now. We know how to do it in these tiny steps, and we know that if we need a little bit of extra structure over here, we'll add it just at the moment when we need it. And we know that we can work in these tiny steps, which helps us create this wonderful self-regulating system where at the beginning I start working in tiny steps, and then gradually I get bored because nothing bad happens, so I take bigger steps until at some point I stumble, and I follow one simple rule. When you make a mistake, like I just did now, slow down. So then you take tiny steps again. And when you take 30 or 40 successful tiny steps, you start going a bit faster, and then you trip again. And as long as you follow this rule that every time you make a mistake, you go back to the tiny steps, then you'll always take steps that are the right size. You'll generally converge to quite a stress-free way of working. And in the process of all this, so by the way, this has all happened in 3 to 7 years of learning. You follow the 4 elements of simple design. You practice writing tests. You learn all the wonderful refactoring tricks like the ones that we saw this afternoon and the ones that I'll be helping people work through tomorrow in my workshop. After 3 to 7 years, you essentially master the fundamentals of programming. I want to be careful there. Master the fundamentals. What that means is that you're effectively programming better than probably 80% of the people around you. Now, I know that sounded awfully arrogant and judgmental. Go with me. There are some of you in this room who know that you can produce value at a significantly higher rate than some of your colleagues, in part because you use techniques like the ones that I've described. Maybe not exactly test-driven development, but you use techniques that allow you to get rid of bugs as your bottleneck, to get rid of design mistakes as your bottleneck, that allow you to essentially work with much less stress and therefore be able to focus more deeply on what you're doing and do it better. Now, those people are almost always the ones who are feeling the most stress, and that surprised me for a long time. Those are the really talented, we call them talented because we don't know how else to describe it, the talented lead programmers, young people who are sort of becoming architects, or the ones who show that they have an ability to deliver value at a rate much higher than the people around them. They're the ones that we depend on. They're the ones that we go to when we have questions. They give us advice, and we follow them. Some of them become thought leaders. Thought leader is not necessarily a bad thing. Thought leader is only a bad thing when they stop having new thoughts. But those people often work with the most stress because there's one basic fundamental concept that they miss, or one idea that they miss. I remember when I was working at IBM early in my career, I was exactly in this situation, and I noticed that I was delivering value at around 3 or 4 times the rate of many of the people around me. Now, this happened because when I joined the group, there were 24 people. When I left the group, there were 675. So there were a lot of people joining at once, and that meant that the bar was relatively low. But one day I found out that I wasn't earning 3 times as much as they were. And I thought, here, I have an opportunity. Another one of these influential books in my career is the book Slack. It has nothing to do with this crazy IRC replacement, but is in fact the idea of having time. I know at a conference where Slack is a huge tool, I make a joke about Slack, ha, 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 whatever. I mean the book Slack by Tom DeMarco, in which he talks about the myth of 100% resource utilization. The idea that, well, if you're a machine in my system, I should make sure that you are working as hard as you can 100% of the time. That essentially creates problems. Again, all rooted in theory of constraints. If you know the theory, you already know the idea. So here I had lots of stress. It was probably limiting my ability to do real work, and certainly was having a bad effect on my mental health. I didn't realize it then. It took about 4 or 5 more years for the effects to really accumulate. I was on the path to burnout, and I didn't realize it early enough. That's part of the reason that I'm up here telling you all this crazy stuff, is because I'm hoping that there are at least 5 people in this room who are on the path to burnout who will get off that path starting today. So, here's how it worked. I noticed that the people around, I could deliver maybe 3 times as much value as many of the people around me, but I wasn't earning 3 times as much money, so I decided that I had some slack capacity. I used this wonderful little trick I call the casino technique. The casino technique essentially means only gamble with the money that you can afford to lose. So here's how it works. I decided that I was going to spend some of my time figuring out how to work with less stress. Some of that had to do with technique. That's when I started to learn test-first programming, test-driven development, and so on. And some of that had to do with managing my own workload and also figuring out how to deal with other people. And the casino technique works like this. You decide that you're going to take some of your time, yes, some of the time that your company pays you for, and you're going to do something for yourself. You're going to learn something, you're going to practice something. It could be, like I said, if bugs are your problem, then it could be test-first programming. If design is your problem, it could be test-driven development. It could have nothing to do with programming. Some aspect of your work, you use theory of constraints and bottleneck theory, you try to figure out where your bottleneck is, and you try to learn something to make that part of your work better. And so, in my case, it was test-first programming, so what I did is I picked a task that would normally take me about 2 days, and I decided that I was going to use test-first programming to try to do it. So I started. And of course, I didn't know what I was doing, so I stumbled all over the place, and it was really slow. And I remember sitting there thinking for 15 minutes, how in the world do I write the test for this one stupid line of code that I need to write? No, come on, I'm here to learn the technique. I'm going to take the time to do it. And of course, I'm watching as the hour hand on the clock is moving. We used to look at analog clocks back then. So the hour, and I knew time was ticking down, but I knew that in the worst case, after about half a day, I could always throw away everything I did and finish the task in a day and a half, maybe a little bit extra. So a 2-day task, I could afford to try to do it the long way, knowing that in the worst case, I might finish that task a couple of hours late. So I did. I tried doing test-first programming. It kind of helped a little bit, but I felt some pressure, so I threw that stuff away, and I went back into the old trance that I knew, just sort of typed a bunch of shit into the computer. It kind of worked, and it only took me 2 hours later than the 2 days that I thought it would take. And so I went to the Friday status meeting, and I thought, oh, somebody's going to yell at me for the fact that I took extra time, and something wonderful happened. Nobody cared. So I thought, well, maybe I could get away with 2 hours on a 2-day task. That's not too bad, like 10% or so. So now I had this idea in my head that I could spend 10% of the time on a task learning something for myself that could, in principle, be good for the company. So I did. That meant that I could afford to throw away 10% of my capacity trying to learn stuff. So now how do you really use the casino technique to your advantage? Well, if you figure out that you can throw away 10% of your capacity on learning, and maybe you'll learn something this time and maybe you don't, you just keep doing that. Keep using 10% of your time for yourself in order to learn things, try things, experiment, and wait for angry emails. Wait for your manager to say, we need to have a talk. And if that doesn't happen and a month goes by, then guess what you try next? 20%, exactly. And if 20% works and a month goes by and there are no angry phone calls, no angry emails, no angry meetings with your managers, then you try 30%. And you keep going until somebody starts to make that face. And now you know that you've made it all the way to the edge. Take one step back. And this is now your spare capacity. What you've done is made an honest assessment of your spare capacity, probably for the first time in your career. And that's going to be useful. I'm going to come back to that in a moment. So now you can use this. What you've done, in fact, is not just looked for ways to try to improve your technique as a programmer, but you've learned an important lesson about spare capacity. That we all have spare capacity, we just often waste it. We waste it on doing work that doesn't need doing. We waste it on doing work poorly. And that if we focus our energy on trying to avoid things that aren't important and do the things that we do well, everything goes faster, everything gets done sooner. Now, how can we really use this idea in general, not just about programming work? So, how many people in the room have heard of or read the book Getting Things Done? Okay, so you can take a nap for about 3 minutes. I don't want to turn this into a Getting Things Done cult seminar. That's not my intent. I just want to give you enough to get started. Getting Things Done is a book and a framework for how to organize your own work. Most programmers never really learned how to organize their work. Nobody taught them. You know, you learned about basics of programming. You learned about why it's important never to store a mutable state in your system. You learned about how to use these weird IDEs to write code in these strange languages to solve problems that nobody cares about. But you probably never learned how to organize your work. And Getting Things Done is one of those ways that you can get started. Now, when you tell me that you don't have time to do things, and then I teach you, no, say you have too much to do. And then you say, fine, JB, I heard you. I have too much to do. If I then hand you a 300-page book to read, your reaction should be, what the hell is wrong with you? Are you kidding me? Right. So instead of giving you a 300-page book to read, let's start with the 2-minute rule. The 2-minute rule says that if somebody asks you to do something, and you can do it in less than 2 minutes, then do it now, get it over with, and never think about it again. And if you do this one stupid, simple little thing, you will gradually start working with less stress. Now, let me emphasize 2 minutes. 120 seconds, not 3, not 4, 2. You'd be surprised how quickly 2 minutes goes by. If you're not sure, then the next time you decide to do one of these 2-minute tasks, make sure to pick up your phone, set the timer for 2 minutes, and you'll be surprised how many times it goes off before you're done. So one of the things that you need to do is sort of calibrate your mind to get used to how quick 2 minutes is. The advantage here is not in getting the small things done quickly, although that's nice. It's that everything else needs to go into your plan. And if you develop the discipline to put everything else into your plan, then trust me, things will move more smoothly. Here's another little trick. It's called the inbox technique. Stupid, simple, and you would think more programmers would have figured it out on their own, but they're so used to just getting into a trance and writing code, they don't think about it. Young programmers, and especially young men programmers, I'm sorry to say, I was a young man programmer at some point, so I get to say this. Young men programmers have this weird idea in their head that thinking about 47 things at once is a sign of strength. It isn't. It's a sign of lack of organization, and it causes you to waste a whole bunch of your capacity on making mistakes. When you work with focus, real deep concentration for the first time, you will wonder how you ever got along without it. So I encourage you to try 2 basic things. The inbox technique is one of them. And that's where, whenever you work, just have a piece of paper or an index card, if you're an old XP guy like me, put right beside where you're working, and every time before you start actually a task, think about all the things that you need to do and write them down. Your goal is not to create a plan. Your goal is to get these ideas out of your head. Write them down. Doesn't matter how much detail you write them down. Just write them down enough so that you can get that stuff out of your head and then pick the first place to start. Maybe it's the first test. Maybe it's the first path through the system. That's what you're going to work on first. And everything else is here in your inbox. Just write it down. There's something magic about writing it down by hand that you don't get by typing. I can't explain it. I'm not a neurologist. So you write these things down. You pick the first thing to work on, and you focus on just doing that. And about 40 seconds later, you go, oh shit, I almost forgot about this. And as soon as you do that, instead of holding it in your head, write it down in your inbox. Get it out of your head, forget about it. Get back to the thing that you're focused on. 2 minutes later, you're going to say, oh, that's right, I'm supposed to do this at 3 o'clock this afternoon. Go over to your inbox, write it down, get it out of your head, get back to what you're working on. This feels stupid the first 3 or 4 times you do it. And then something magic happens. I remember the first time it happened to me, I'd been working for about 2 hours, faithfully putting stuff in my inbox. And I was working on a particularly annoying problem, and I finally got it working. I finally had my test passing, and I went, boy, I'm glad that's over. I'm finally done. So then I looked at my inbox, and I realized there was something right here that I needed to do before I finished. I thought I had finished my task. There was one thing left in my inbox that was important. And the first reaction I had was, oh, shit. I thought I was done. And I was angry about it for about 20 seconds, and then I realized, hey, wait a second. I didn't waste any mental energy on that in the last 2 hours. For the last 2 hours, I just focused on getting this work done, focusing on doing it well, not making any mistakes. And then I looked over here, and it was like I had a friend reminding me, hey, one more thing. I promise just one more thing, and then really you're done. I didn't waste any energy on that for 2 hours, and that's when I really realized the power of the inbox technique. This is one of the few little stupid tricks that I've learned that has taken so much stress out of my work, I can't tell you. It almost sounds too good to be true. I encourage you to try it. And if you combine that with a technique like either Pomodoro technique or monotasking or any of these sort of work for a short burst of uninterrupted time, then take a break, any of those tricks, inbox technique plus that together really makes a big difference. And it helps you start to not completely, that was stupid. It really helps start you organizing your work. And yes, it feels a little weird the first time that you spend 30 minutes working uninterrupted and no one's allowed to talk to you and you think, oh no, my coworkers are going to hate me, I'm not going to be responsive. Trust me, the world can wait an average of 15 minutes for you to talk to them. So between the 2-minute rule, the inbox technique, and something like Pomodoro technique or monotasking, you really start to move not only in the direction of organizing your work, but in the direction of working with significantly more focus and concentration. And again, I didn't think this was a big deal. 26-year-old me would have thought that this was a load of bullshit, that this is just psychobabble that doesn't matter. And 43-year-old me really grew to appreciate it more. And 45-year-old me, boy, my voice should crack when I say 45, 45-year-old me can't imagine living without it. That in the moment when I'm working on something, I can give it my full attention for 20 or 30 minutes, and the rest of the world doesn't matter. As long as nobody is in threat of death, as long as there is not a fire in the room around me, I can focus on this and work on it and get it done. And at that point, when I started to really practice this, my slack just grew. I was compounding all this slack capacity because the more slack I felt, the more justified I felt in focusing on one thing at a time, the sooner I got things done and the more slack I created. And then eventually, my bottleneck had nothing to do, well, I was going to say it had nothing to do with me, but that's a huge lie, was it seemed like it was about other people. See, I grew up as one of these kids who had no idea how to talk to people. And so at the age of 12, when home computers became common and affordable, I thought, oh, great. Here is a thing that will do what I tell it to do. Here is a thing that I can understand. Here is a thing who will not judge me for wanting to play with mathematics. Here is a thing that will allow me to build a relationship that I actually care about. I was 12. What did I know? See, my father-in-law is one of these weird people who grew up somehow knowing how to get along with other people. So much so that he was that kid in the playground who would convince all the other kids to play the game that he wanted to play, and he would make them believe it was their decision. I did not have that skill. And I'm going to guess that there's at least a few people in the crowd who can relate to that idea that, you know, I got involved in computers because they did what I told them to do and I understood them, and these weird bags of meat just didn't make sense to me. So I did the only sensible thing. I decided to pursue a career path in which I would never have to worry about bags of meat and could focus on talking to a computer until I got a professional job as a programmer. And the first thing that you learn, other than here is your computer and here is, you know, where the coffee machine is that 95% or more of the problems that you deal with as a professional software person have nothing to do with the computer and have everything to do with those weird bags of meat. So, okay, how did I learn to play well with others? I had to be taught because I just didn't learn it growing up. I didn't understand it. I was the kid who knew stuff. And so, of course, when I talked to the other kids in my school and I found out that they didn't know stuff, I would try to teach stuff to them because that's what a good person does. Is, you know, if you need to know things, I teach you these things and everyone will get along better. And I couldn't understand why they kept punching me. So clearly I had a lot to learn. And fortunately, in my late 20s, I got a chance to start attending a conference called Amplify Your Effectiveness. Sadly, it doesn't run any longer, where I got to meet Jerry Weinberg, who introduced me to some of the ideas from Virginia Satir, who was a family therapist. And at some point, a bunch of people, I don't know who, somebody realized, hey, this stuff works well in organizational dynamics, that businesses sort of behave like families in some very important ways, and so some of these therapy ideas can help us in operating better as businesses. Now, at the micro level, one of the things that I learned about was the Satir interaction model. This I like to think of as a way of debugging bad interactions with people. So what do I mean by a bad interaction? So you interact with somebody, and maybe one of you raises your voice, and the other one raises their voice, and pretty soon you're screaming at each other in a meeting room, and you were supposed to be talking about design. Or you're screaming at each other in a meeting room, and you were supposed to be planning what we're going to do for the next month. So if you've ever been in this kind of situation, how do you cope? I never learned how to do it as a kid, so I had to be taught as an adult, and this is what I learned. Rather than talking through the entire model, I promise you can find wonderful resources online. Just look for a Satir interaction model. It'll be in the notes that I promise you are there. But I want to talk about the core part of the model, the part that really surprised me. Another one of those, just like how too much to do did this to me, when I learned about this part of interacting with people, it drastically changed the way I acted in the world. It's probably safe to say that this one idea more than any other drastically changed not only my stress level in my work, but even in my life in general. And I call it the fundamental irony of interaction. See, the way the model works is that essentially there are 4 stages. The first 2 aren't so important right now, but the last 2 are called significance and response. So I do something, like I walk over to you and I start talking directly to you, and you start making up a story in your head about why I'm doing this. You're attaching significance to it. And so then you respond somehow, like you're doing right now. You're responding by trying very hard not to move Now you laugh because they laughed, which means that it's socially acceptable for you to laugh now. Okay, and we already see that there's a feedback loop going here. So that's part of it, is that remembering that these interactions are feedback loops. Significance has to do with what is the story that you tell yourself about why he, meaning me, decided to say this thing this way right now. Why did he suddenly come to the front of the stage? Why is he lowering his voice? Will he ever get to the point? Significance is that story that you tell yourself about why the other person is acting the way they're acting. And based on the significance, then you move to response, which is obviously how you respond. Now, if you've ever been in a bad interaction with another person, the thing that makes it a bad interaction is usually their response. And then your response back. And then their response back. And your response back. And we get locked in this death grip where each one of us is objecting to the other person's response. And so then we even directly criticize their response and try to get them to stop responding that way. That's where you say, stop hitting me. The fundamental irony of interaction is this: the path from significance to response, meaning how you respond after you have interpreted what's going on, is instant, deeply culturally conditioned, and perfectly rational. It happens this quickly. When I say culturally conditioned, it means that you have been taught how to respond since you were old enough to understand your mother language. And big people who seemed important were giving you life lessons about how to act. And you got some of those directly from people, you got some of those from the culture of the city you grew up in, the family you grew up in, the region you grew up in, the media that you consumed, television, radio, internet, conversations with people. Any of that stuff taught you how to respond. And so that's what I mean by deeply culturally conditioned. Really in there, almost impossible to change. Not only that, but you shouldn't change it because the third part is that it's perfectly rational. This was for me the hardest part to understand. That the way you respond, once you have chosen an interpretation of what's going on, once you've told yourself a story about what's happening, the way you respond is perfectly rational, which means that if I grew up the same way that you did, with the same cultural conditioning, in the same situation, I would behave exactly the same way. And that was the thing that really made it difficult for me to understand. That was the thing that when I decided to accept that as a reality, everything changed. What that meant is that in a bad interaction, when you are yelling at the other person to stop yelling at you, when you're telling them stop hitting me, when you're telling them to stop saying that silly thing, stop bringing up this thing that I said in the past, stop writing these passive-aggressive emails. When you keep attacking their response, you're attacking the thing that is the hardest for them to change. You might as well just be shoving a knife in your stomach. It has the same effect. Instead, focus on the significance. The fundamental irony of interaction is that you're probably not going to change their response. So instead, focus on their significance, their interpretation. If people are responding in a way that makes you nervous, that surprises you, that upsets you, then take a moment and try to offer them another way to interpret what's going on. Here's a simple example. You and I, at some point tonight, underground, are probably going to end up in a conversation. It's going to be loud. There's going to be some music. There are going to be lots of people talking. And at some point, while I'm trying to make eye contact with you, I'm going to have a tough time hearing you, and I'm going to do this. And by looking away and sort of unfocusing my eyes, it's going to look like I'm not paying attention to you anymore. Or you could understand that this is me trying very hard to pay attention to you so that I can actually hear you. Offering people a different interpretation of what you're doing can go a long way to changing how they respond to you. Now, here's where I want to end. In the beginning, I started to use the satir interaction model as a way to debug other people. That was my idea. First, I used it to debug bad conversations. Then I started to use it as a way to debug other people. Why do you behave in that strange way? Aha. I bet you're interpreting it this way. Have you thought about interpreting it that way? I promise you, when I do this, it's not because you're boring, it's because you're interesting and I really want to be able to hear you, and this is the easiest way for me to do it. That's me offering you another interpretation. What I found, though, is that really, the satir interaction model gave me a way to better debug myself, to understand my own interpretations. And so one of the things that I realized, probably in my early 30s, was that I was a judgmental asshole. And I thought maybe this would be something for me to change. So I started. One of the little tricks that I used is EPrime. That's the English language without the verb to be. So if you're a native English speaker, try communicating this coming week. All your written communication, do not use the verb to be in any of its forms. Just try it. You'd be surprised. If you can't label things and you can't label people, it's harder to judge them. So I spent about 15 years practicing that. And then I realized that my bottleneck right now isn't being a judgmental asshole, although it is occasionally a problem, that my bottleneck now is being an impatient asshole. So that's what I will be working on over the next 15 years. If anyone has some interesting little tricks to help people develop more patience, I'd really like to hear about them tonight. So the well-balanced programmer is someone who pays attention not only to the quality of their code, but also to how to organize their work and how to navigate the people they work with. And I think that if you haven't been paying attention to those other two areas of your work and your life, I hope that a few of these tricks will help you get started. And if you'd like to talk more about that with me later, I would be happy to do that. Thanks very much for your time and attention.